In this video, we're going to have a look at assumptions of an ideal gas as well as important equations relating to ideal gases. So just to start with, there's this sort of, I believe it's called an acrostic poem that I used to remember about an ideal gas called Raved. That's how I used to remember everything relating to an ideal gas. R standing for the fact that there's random motion of molecules in an ideal gas. A standing for attraction and the fact that there's no attraction between molecules. V standing for volume and the fact that the volume of the molecules is so small compared to the volume of the whole gas and the container itself. E standing for elastic collisions, meaning that collisions that do happen between molecules of an ideal gas, they transfer all their kinetic energy onto the other particle. None of the energy is wasted. And D standing for duration and the fact that the duration of time during impact is a lot smaller than the duration of time spent in between contacts. Let's go on to a calculation using ideal gases. So it's given you a temperature in degrees. We're probably going to have to convert that into Kelvin, which you do by adding 273. It's told you the volume, 0.2 meters cubed, and it's also told you the pressure, 1.6 times. That's 10 to the power of 6, by the way, in case you couldn't read that. It's very small for some reason. It's asked for the number of moles. So automatically what comes to mind is the equation of an ideal gas. PV equals N, capital R, capital T. And you want to rearrange for the number of moles. So it's the pressure times the volume divided by the molar gas constant, which is given in an exam, multiplied by temperature. The pressure is it is stated. Sorry, my mind went blank. 1.6 times 10 to the 6 multiplied by the volume is 0.2 divided by the molar gas constant, which is 8.31, multiplied by this temperature that we have to convert into Kelvin. So 22 plus 273 is 295. 295, you put all of that into your calculator and it will give you a value of 130.5. Great. Let's go on to the next question. So it's given you a molar mass, 4.3 times 10 to the minus 2, and it's asked you for the density, and also asked for the unit. So density is mass over volume. We have the volume, it's 0.2 times 10, or just 0.2, sorry. But what's the mass? It's giving you a molar mass, and if you multiply that by the number of moles, that'll give you the number of kilograms, which is the mass. A little trick, because this is kilograms per mole, we know that if we multiply by the number of moles, they'll cancel out, giving you the mass in kilograms. So do look out for that. So the mass itself is the molar mass multiplied by the number of moles, which we calculated as 130.5. If you put all of that into your calculator, you'll get the density value, which is 28. Mass is in kilograms, and you're dividing by volume, which is in meters cubed, so kilograms per meters cubed. Great. If you have any questions with that, just let me know in the comments, and if there's any specific question you'd like me to go through next video, just let me know too. Otherwise, please like the video if you enjoyed it, and be sure to subscribe, it'll mean a lot, and yeah, turn your post notifications on. I'll post a new video every single day.